So the average minimum time to drive a mile in a sedan is claimed to be greater than, was it 14.7?
Yeah.
So even before you start, the very first step must be to write the definition properly, because if you mess this step up, then everything is going to be wrong at the end. So start with null and alternative. The statement that we have in the claim, which is mu greater than 14.7, should I write it over here or there?
Over
Right.
here.
Yeah.
Over here, what? You said over here or there? So
Yeah.
over here.
Oh, I see. And which is the claim?
Over here.
Over here. Over here. So if that is mu greater than 14.7, what is the opposite statement?
Use less than.
Less than or equal.
Alpha is given, alpha is 0.1, we can make use of it later. The test statistic T is equal to x bar minus mu naught divided by s over square root of n. Do we know the mean?
Yes.
Sample mean, yes. We know the sample size because that information came from those 22 sedans. We know the sample standard deviation. Also, do we know the value of mu naught?
Yes.
Yes, and that value is 14.7. So 15.4 minus 14.7 divided by 2.1 over square root of 22. And what is that value?
1.56.
1.56. So now that we have the test statistic, we can use the alpha value to determine whether to reject the null or otherwise. So even before we start, is this a right tail test or a left tail test or a two tail test?
Right.
Why?
It's pointing right because the arrow is pointing.
What's pointing?
Greater than.
The arrow
The arrow.
over here.
There is no arrow. This
There
is
is
a
an
right
arrow.
hand side.
The alligator mouth is pointing right.
Okay, so since we have greater than,
The
we
mouth.
have a right tail test. If it is a right tail test, the rejection region is on which side?
On the right side.
The right
It's
side.
this way.
The right of it.
It's open this way, it's pointing that way.
The area that is shaded is 0.1. So how do we find the critical value?
There's the 1 minus alpha, then truth.
Okay, where's pointing?
So inverse T, 1 minus alpha, 1 minus 0.1, n is 22. 22 minus 1 is 21. And what did that give us?
1.32. That one.
So the number right there on the real number line is 1.32. The rejection region is anything above 1.32. And here we have a test statistic that is 1.56 which lies right there. Should we reject the null?
Yes.
Yes.
Yes. If we reject the null, do we have enough evidence to support the alternative?
Yeah.
Well, reject the null. I rejected the null. So we found evidence towards the alternative. Is the claim true? Or do we support the claim with the evidence? Yes. So there is enough evidence to support the consumer group's claim. Good?
I have a question.
Yes.
So like, I'm just generally confused. So how do we know if we can say the claim is true or not? Is it if the test statistic falls in the area?
So if the test statistic falls in the rejection region, we reject the null.
Okay,
That's all we do.
Okay.
In this problem, I've rejected the null. In other words, I found support toward the alternative, and the claim happens to be the alternative. So you found evidence to support the claim.
so it's whether or not, so after doing the test statistics, you're able to say if it falls in the reject, the null zone, then you can support the claim.
Yes. It's going to vary from problem to problem. So that's why I said the very first step is crucial. You mess this stuff up, or if you don't write it, you're going to have a hard time, the very last step. So this is one way to come to a conclusion. There is another approach, which is the p-value approach. We have a right tail test. So the p-value is the area above the test statistic. So to find critical values using a t-distribution, I made use of inverse t. How did we find probabilities under a normal distribution curve? What function did we use to find probabilities? Area under the curve
Inverse T.
with a normal distribution.
Normal CDF.
Normal CDF. In this case, we have T CDF. So pick up your calculator, go to second bars.
Which way do you think is easier?
What do you
You're
mean?
showing us another method, right?
Yeah.
Which way do you think is easier?
In practice, this is what we use, but in homework and on the exam, it could be anything.
What do you recommend?
It could be anything. So in practice, we would use the p-value approach. So I believe it's option number 4. Do you see TCDF?
It's 6.
Yeah.
6, okay. TCDF, we want to find the area above the test statistic. So the test statistic is over here, and I want to find the area above it. Even before I do that, let me ask you this question. Is that area going to be bigger than 0.1, or is it going to be less than 0.1?
It won't be bigger.
Look at that picture.
Less than,
Why, Alex?
because we have an area of 0.1 from the critical value. So if that's more to the right, it should be small.
So this is the area above the test statistic. That is the area above the critical value. Clearly, the area above the test statistic is smaller than the area of 0.1. So what do you think the lower endpoint is?
1.56.
1.56. Where does the area end?
Infinity.
In 99. With the normal distribution, we enter the mean and the standard deviation. In this case, it is a GCD. So if you have to take a guess, what should the next term be?
Degrees of freedom.
Degrees of freedom. And in this problem, it is 22 minus 1 to 21. What is that value? It better be below 0.1.
0.066852065. That one.
So what is this? Yes.
It's 0.06685. Yeah, 66.
So what does the p-value tell us? Well, when we started the problem, we said the maximum probability of type 1 error. In other words, the amount of error that you will tolerate, maximum amount probability of error. If you rejected the null when you should not have, that's what a type 1 error is. So I was willing to tolerate all the way up to 10%, but nothing more than 10%. But I did the test and the data is telling me, well, you set it at 10%, but in reality, the chances of the probability that I will commit a mistake in rejecting the null is only about 6%. So did it exceed my expectations in terms of performance, in terms of error?
No.
Why not?
How would it exceed?
Well, in terms of error, do I want to make less error or
Yes.
more?
Yes.
Less.
Correct.
So the probability of error, if it goes below my expectations, are going to go up. Correct? The test is doing better.
Right.
That's what I'm asking.
Yes.
So did the test exceed my expectations in
Yes.
terms of probability?
Yes.
Yes.
Okay.
So that is the p-value, and it is the area above the test statistic for a right tail test. Good? Okay.